In this video, I'll be showing you how to use HEMI2 inside of BlueSpray. First, we need to get BlueSpray, and you can do that by going to our main web page, gsp.humboldt.edu. Then go to the ISAM page, Technology, BlueSpray, then the BlueSpray website, and then to the download page. This website also includes information on how to install Java, which you will need to run BlueSpray, but that's all you need. I would just then download the latest version, which will be at the top of the list. It's going to take a little bit of time to download, so I'm going to go ahead and close this and show you that I already have a version here sitting on my desktop. And once you have Java installed, all you have to do is go in here and double click on bluespray64.bat. Now this will run a default batch file for BlueSpray. Sorry, I've got to move everything around so it's in my video window and fits on YouTube. Okay, so it'll run this version. Now this version allocates a certain amount of memory. You can increase that amount of memory. This is set to 6 gig. This is kind of a confusing string of gobbledygook, but the website explains how to modify this so that you can increase or decrease the amount of RAM. BlueSpray is kind of a hog for RAM. So if you use big rasters, you will need to up the amount of RAM that it can access. Okay, so this is BlueSpray. Just really briefly, it's a GIS package that I created. It's a little different. It has a view like other packages do. The way you add data is typically by going here and saying add it from a file, or as I'm going to do, just drag and drop. Pretty much you right click on everything to do anything, and then there's the traditional tools up at the top. So what I have over here is I already have a folder set up with some dug for presence points, and I tend to just drag and drop things into BlueSpray. It may pop up with a few dialogues, which typically you just click OK when they come up. You can pick the XY column as you can in ARC, or if you have it labeled lat long, easting, northing, that kind of thing, it will just pop up. Then, with the correct selections, then you can right click, zoom on any layer, and it will zoom into it. So here you see our typical dug for presence points for California. I've also got a bunch of bioclimate data for California that we've worked with before. I'm going to drag and drop some of those in. Annual precipitation, minimum temperature of the coldest month. Let's do maximum temperature of the warmest month. The kind of things that we would expect plants to, that would determine the distribution of plants. Okay, as with other JS packages, you can grab a layer and move it up and down. You can change the symbology, but really for this, I just use it for doing the habitat maps, and then you can bring them into ARC or QGIS and create your final maps there. So here's our layers. One thing is that if you load a lot of layers, and they're big layers, which I don't recommend doing initially, like with all modeling with rasters, I recommend doing a small area or very low resolution first until you're used to the software and the process, and then go and do larger ones. But you can turn them off as well, which will help your drawing speed. And the same is true with the points. And again, there's more tutorials for BlueSpray available on the BlueSpray website. But let's dive into HEMI. So if you right click on the presence points and then go to Wizards, HEMI2, there it is. It will open up, and this first dialog allows you to pick the covariates or the independent variables. You can add them one at a time, or just click Add All, and it will add all the rasters that are currently loaded into BlueSpray. Now be a little careful with that, because once you start making maps, I tend to accidentally add my habitat suitability maps as covariates, which is not what you want. But again, you can delete them. You can add them one at a time. Then when you click OK, it's going to launch the main HEMI2 window. So this is the main window or dialog box where we can evaluate our models and create them. So, excuse me, across the top you see a few buttons that we'll get to in a second. Each of the column represents one of the independent variables, and then here's an image of the independent variable. There's a histogram that we'll talk about quite a bit in just a moment, a receiver operator curve, and then some of the statistics. This first button will load the data, so it really doesn't do anything different than we just did. The next button will fit the model to the data. You can actually watch it do that, especially with larger data sets. You can even go in here and mess with it, modify the model, then go ahead and click the second button again, and it will fit the model to the data. Okay, the third button creates a habitat suitability map, and then you can actually right click, send that to the scene inside of Blue Spray, and there's our model. So I need to say, first of all, as you can see, it's very easy to use, but we don't want to go too fast. You may want to do that just to get a first one out, see that you can get it here. You can then right click on your habitat map, export it to a file, save it to a TIFF or an IMG, and bring it into ARC. So the overall process is pretty simple, but we want to dive into it in more detail so we really know what's going on. And I'm going to take a look at annual precipitation here. And as you can see, you can grab the edges of things, particularly at the bottom and the sides, to make things look bigger. And this is really where the interesting things are happening, is here with the histograms that you've seen before in my presentations. So again, what we have is we have the green line, which represents a histogram for all of California for annual precipitation. Then we have the red histogram, which is the occurrences for Doug fir in California, or our occurrence points, I should say. Both of those have been scaled to 1, so they look similar, and it's easy to take a look at your histogram. And then we have the Doug fir occurrence histogram divided by all of California, and that's where you can see that this blue area, which is also known as F sub z over F sub z of 1, I think, F sub z of L, I should look that up, that Maxent uses. Identical approach as far as computing this blue area to Maxent, because that really represents how prevalent, and there's some discussion over this, but it's how prevalent do we believe Doug fir is versus the amount of habitat that's there. So if you have a lot of habitat and a lot of Doug fir, you're going to get a lot of, if you have a large area of habitat that's compatible with Doug fir, you'll get a lot of Doug fir. If you have very small areas of habitat, like we do here with very high precipitation, you might have just a few Doug fir, but that area is saturated with them, so that's actually very good habitat. So that is again the reason we want to use this, the divided histogram, when dividing the Doug fir occurrences by all of California. Okay, so as we look at the rest of the interface, we see the receiver operator curve, and notice that the way HEMI works is it actually operates on each response variable independently, and it computes excuse me, the model for each one. It also computes a ROC curve, or receiver operator curve, for each one, and it even shows how that one is contributing to the overall model. And here we can see that precipitation looks a lot like our final model, so it's probably contributing the most. Even more importantly, down at the bottom we have our AIC values, and this represents, AIC and AUC, and especially the AUC represents how good is the area under the curve, or what's the area under the curve score for just that one independent variable being used to create a model. So this whole column is just looking at one independent variable, annual precipitation. This one's looking at max temp warmest month, this column at min temp coldest month. So these performance values are just for one independent variable being applied to a model at a time. Then those are combined together by multiplying them together to get our final model, okay, which in this case is interesting. It actually drops in AUC value a little bit. Curious. That actually surprises me, but there it is. There's our final model and our final ROC curve. So we've got an AUC of 0.89, which is pretty good. 0.894 here, 4.9 and 4.1 here. So this one is actually being a little better. Curious, but we'll talk a little more about gaining more confidence with that in a second. So that's it, and then we send it to a scene, and then we have it here. Now you might also want to include one of these charts in your report. You can right click on them and copy that as a raster to the clipboard. You'll want to fix the aspect ratio. So here I'm going to make this 500 by 300. And then I can go into Microsoft Word and paste that. And I've got my graph that easily. Now notice it doesn't fit quite perfectly, so you might want to crop this either in Word or in a paint package to make it look better. Please do not, stretch it this way, because then all of the text looks stretched. Okay, so that's it for the basic HEMI, and I'm going to come right back and do some Monte Carlo.